Welcome to my first nostalgia programming project. This project came about when I was cleaning my shelf. I saw this book, Database System Concepts by Henry F. Korth and Abraham Silberschatz. It was a textbook from my class back in university. Apparently, it was also called the Sailboat Book because the cover has had sailboats since its first edition. We used the first edition, and I can honestly say that I do not see any sailboat on the cover. The first edition was published in 1986, and I went to university much later than 1986. In that database class, I was expecting that we would pop up the hood and see how database systems worked at the low level. However, we were mostly writing and running SQL queries in that class. After reading parts of the book, I decided to write from scratch a generic database in C. I will use the book as a conceptual guide. The project is expected to grow in complexity as we implement more features and modules. So according to Korth and Silberschatz, the database has the following components. The file manager. The file manager manages the allocation of space on disk storage and the data structures used to represent information stored on disk. The buffer manager. The buffer manager is responsible for transfer of information from disk storage and memory. The query parser. The query parser translates statements in a query language into a lower level language. The strategy selector, which attempts to transform a user's request into an equivalent but more efficient form, thus finding a good strategy for executing query. The integrity manager, which tests for the satisfaction of integrity constraints and checks the authority of users to access data. The recovery manager, which ensures that the database remains in a consistent state despite system failures. The concurrency controller, which ensures that the concurrent interactions with the database proceed without conflicting with each other. So here is a diagram of two things, the user and the disk storage. The disk storage is where our data will be stored. Essentially, a database needs to be stored uh, in an offline or an, a disk so that when the computer is off, the data is still saved. So from the user to get to the disk storage, there are many things that it has to go through before the data can be retrieved. So the user uh, interacts directly with a query parser. So it can be in the form of an SQL query, for example, and in the SQL query, the user can specify what kinds of information he or she needs from the disk. The strategy selector then looks at the query and decides on the appropriate action to take, uh, thereby optimizing uh, the query. For example, it can look at the buffer manager, and if the information is already in memory, it can be accessed right away without even going to the disk. Otherwise, if it is not in memory, then it is the responsibility of the file manager to retrieve the information from the disk. So once the file manager finds the correct information, it is often uh, temporarily stored in a buffer, and then the information is then passed on to the user. So for our project, we will be developing from the ground up, meaning to say we will first organize our structures at the lowest level, which is the disk, and build our way up until we reach this level of the query parsing. So we will start with the really simple data structures and functions and then start moving up. Uh, Now, as already mentioned, there are other components of the database system. For example, the recovery manager, the integrity manager, and the concurrency manager. But for this project, we will not be programming them. Maybe in a much later project, more enhancements, more complicated modules, then we will include these things. Okay, so now you see the overall direction of the project. Now let's take a look at the first phase of the project, which is we will design the file manager. So we need to take a look at what needs to be stored in disk. So there are basically four groups of files that need to be stored in disk. The first are the data files, which store the database itself. The second is are the system data files, which store information about the structure of the database. This is also where the data dictionary is stored. The index files, which provide for fast access to data items holding a particular value. And statistical data, which store information about the data in the database that can be used by the strategy selector. So this is often used for optimization. So uh, let's look at the hierarchy of the data that we are going to store in the database. So in the disk, we can have one or several databases. And here is the limitation that we will impose on our program, how many database we can store in the disk. Per database, we have one or more tables, and per table, we have one or more columns. So N here, as I've mentioned, is just the limitation that we will impose on our database. And for our project, it is between 1 to 255. Now, why 255? Why not 300? Why not 100? Well, it's because there is a data type in C that maps directly to these values as we will begin programming. So the system data structures, it will become complicated, but in the beginning, it will look like this. We have a database with an ID. The ID will range from 1 to 255, 255. As we add databases into the system, we will increment this. So it works like an auto increment, but it will be our responsibility to assign a unique ID for every database. And then the database name, which is text. The text we can uh, decide later how big is the text for these things. And the table ID looks very similar. It will also have an ID number, which will range from 1 to 255. Then it will have a table name, which is also in text format. And then, as we mentioned, uh, column or in other database terminologies, they're also called fields. Each one will have a unique ID, which is auto increment from 1 to 255, and then the user can specify a name for that. So, but what is the problem with this structure though? Uh, as you will see, there's something missing because how can we now link this table to a particular database, this column to a particular table? So to solve that problem, we need a way to link these things together so that they will fall in the hierarchy. So for example, we need to add a database ID here, which will correspond to the ID here. And similarly, we need to add a table ID, which will correspond to the table it belongs to. So in a way, we are already creating a relational model for our system data structures. So remember, we will have multiple databases, and per database, you have multiple tables. So this will solve the problem. because this ensures that a particular table will belong to a particular database and a particular column will belong to one table. So it's a one-to-many relationship. So that's it for the introduction and design of this project. See you in my next video as we try to implement our data structures in C. So see you in my next video, and please subscribe and leave comments. I love questions, comments about anything, and maybe even ideas for future programming projects. Thank you, and see you in the next video.